Hello, y'all. This is Darryl Jr. Looks like my volume is okay. Here for a different type of show, talking about some science instead of some dirt. So I'll talk a little bit about what I'm doing. I know some of you have seen the short live video feed I did when I was out there with the equipment. And show you real fast I'll get to that. I'll show you real fast the device. So this is my solar telescope set up where I was right outside of my dorm. It's actually a pretty interesting spot because it ended up such that the sun, so it's like a little, dip in the building, and the sun actually went straight through the opening. So I was able to get a view of the sun across the arc of the sky until it hit the sort of top of the building, the dorm itself, and the top of the trees across the street. But I didn't really have to worry about that because I recorded about 4 hours in between, the sun being in the middle. And be sure, by the way, if you haven't already, like and subscribe. Help me get to 1,000 subscribers. And I'll also be offering some tutoring if anybody's actually in school studying, uh, up to, let's say, sophomore, junior level science, physics, astronomy, a little bit of chemistry. Or if you're a flat earther and you don't want to be dumb anymore, basically, you want to actually learn something rather than just making up stuff as you go and believing people who are lying to you. Uh, contact me. We can go over how the Earth is a globe and the math and the science behind it. So I'll switch actually to my food. Oh, well, I guess I should have. I tried to add a different whatchamacallit. So let me just stay on this screen then with all the stuff on it. And I guess I have to do more work on the other one. I'll fix that later. Thanks for letting me know, Hart. Thanks for letting me know. Awesome. So let me say what I said again. My dorm is in the background, and you can see the telescope right there. And the way the dorm is set up, I'm sure they didn't design it that way. At least I don't think they did. Like you could see the telescope pointing at an angle going towards the back of the dorm, and the sun sort of arced directly, almost directly overhead, and then across the street to the other side. So right now it must be about 11 o'clock, 11, 12, somewhere around there, and you could see the angle the telescope is pointed to the left. At around 3 or 4 o'clock, it'd be pointed to the right. So that's the angle that the sun is going. So these are my images here, and I'll actually pause the what do you call it, slideshow if I can, and I'll discuss a little bit of the images, so which I'm actually pretty proud of. So let me find a pretty good one here. Let me back it, increase the size. So I took 4 hours of images, and I know the one on 113 was a good one. 127, 123. Ah, here's a good one to stop at here. So what I'll do, I'll go ahead and unlock it, and I'll increase the size so you can see some good sunspots on the sun. So I know, and I remember, I think you were mentioning that as well. The flat earthers, the whatever kind of globe denialists talk about the sun being electric. These people never really do any real astronomy, like actually study the sun or study it properly. Like I've seen people some of the flat earthers or whatever look at the planets or the sun, and these people just don't know how to use telescopes. They don't set them up properly. But this is the sun looked at through a telescope that's properly focused and set up so that you can actually see details on it. And to see that is not like some electromagnetic thing. Those that has a pretty firm boundary. Now, it was actually pretty hot that day. So looking through my digital camera, you can actually see the air, the waves in the air, how it sort of roughened the edges a bit. So, but I first started doing solar astronomy in the winter when it was pretty cool. So the air was not as hectic, and I didn't see those the waving. It's similar to like when you're driving down the street or walking down the street, and the asphalt is really hot and you can see like the ground, like the ground sort of wavy. You can see the wavy air, and it looks sort of hazy like that, like you can see the air how it's waving. It's basically the same thing in the atmosphere. If you're higher, we just can't normally see it unless we're looking at something that can show the background of it. Now you could also see that sometimes there were clouds going through the in front of the sun, but I didn't worry about that. I just wanted to. I'll get into why I was taking pictures as well. Here's another good one as well. You can see some pretty good detail. And I'll zoom in on the sunspot. That's pretty good. So what happened is I found the setting on my digital camera that sharpened the image. So actually didn't actually bring some of my earlier images. My early images was horrible. If you go to my website though, you can actually see some of my earlier images. I actually made a page called Solar Astronomy. I'll make a part two. I've already started the part two page, but I just haven't finished uploading images. But you could take a look and see some of the earlier images and see how I've been improving over time. And what I'll do is pull up my one of my astronomy textbooks. Haven't actually researched in a while with solar spots, with sunspots, so I know they deal with the activity that's going on in the sun in a certain area. But I'll go ahead and pull it up and take a read, and we can review what those sunspots are before I go into what I'm doing with the sunspots and how I'm looking at it and what my ultimate goal will be. Right? So it says, so I'm on page 42 of one of my textbooks, Astronomy Today. And it says, well, it's talking about how Galileo was looking at sunspots. Uh, apparently there's a cycle, right? So ironically, by the way, the sunspots there, those things are like the size of the planet Earth. You can get into the size another time. The sunspots. It says, Uh, an optical photograph of the sun shows numerous dark blemishes on the surface, as we can see there. First studied in detail by Galileo in 1613, the spots provided one of the first clues that the sun was not a perfect unvarying creation, but rather a place of constant change. The dark areas are called sunspots and typically measure about 10,000 kilometers across, approximately the size of Earth. So each one of these areas is about the size of the Earth. When I pull up some ones from the Soho satellite, we'll be able to see in more detail. Because even though these pictures are pretty detailed, the Soho satellite is even more detailed because it's in space. It doesn't have any atmosphere in between it. And it says, as shown in the figure, as you can see in my images, they occur in groups. So as you can see, that this is one group of sunspots here, another group right there. So they pretty commonly occur in groups. You can see some groups on the right side. And in any given time, the sun may have hundreds of sunspots, or it may have none at all. Hey, what's going on, Logan? So I'm talking about some of the solar research I'm doing. And this particular, I'll talk about how I'm going to determine the rotation of the sun, how high it's rotating. And right now, we're talking in detail about sunspots, what they are, and some of the best pictures I took recently on the 3rd. And I'm going to, in a bit, I'll show you all the video I have put together where you'll be able to see the rotation of the sun just a little bit. In that 4 hours time, you can see the rotation. Sunspots, studies of sunspots show an umber or dark center surrounded by a grayish penumbra. Now, the thing is, I didn't actually know that when I first started taking pictures because Um, when I first started taking pictures, I wasn't as good at it. I didn't understand my camera as well, so I didn't make use of the focusing aspect of my camera. It wasn't until the third that I saw. Let me see if I can find a better one that shows the center area and the outside area. So you can see it there, but there we go. Here's a pretty good one. Let's see if I can find one that highlights it better. Because at different times there was clouds going in front of the sun, and when the telescope was pointed very high, my camera's pretty heavy, and that was actually causing problems for the telescope. I have basically an El Cheapo solar telescope. I'm actually the camera actually stripped. Oh, here's a good one. The camera actually stripped the little thing that was holding it in. The last time I went to take pictures, I only got one good picture that day, but I'll have to do some work on it to readjust that. But suffice it to say, if you look at the sunspots there, you can, for instance, see the darker area in the center, and you can see a grayer area around there. So when I first started taking pictures of the sun, I didn't see that. I only saw that on the third, and then I realized, wow, there's some more detail there. And now I'm reading, it says studies of the short sunspot. So obviously I'm new to astronomy. So the people who actually do astronomy for a living, been doing it for years, they know about this already. So I'm reading it in a textbook right now. Studies of the sunspot show an umbra or dark center surrounded by a grayish penumbra. Close-up views show each of these dark areas and the brighter undisturbed photosphere nearby, which is, in other words, there's the center spot, there's the gray area, and then around there you can see the sort of, in the picture it looks sort of whitish because of the filter around that area. It says gradual change. Oh, and it says the darkness is really a gradual change in photospheric temperature. Sunspots are simply cooler regions of the photospheric gas. The temperatures of the umbra is about 4,500 Kelvin compared to the penumbra, which is 5,500 Kelvin. The spots then are certainly composed of hot gas. They seem dark only because they appear against an even brighter background of 5,800 K. So in other words, the area that's not darkened is 5,800 Kelvin. The slightly gray area surrounding it is about 5,500, and the umbra, the dark center, is 4,500 Kelvin. And so all of these things are pretty bright. Like if we was looking at a star that was 4,500 Kelvin, it would be extremely bright. We would still need a solar filter to look at it. But that particular spot, surrounded by the brightness of the general temperature of the sun, it looks dim, looks like a spot. So I think that's pretty cool. So I really like stars. When I go to graduate school, I plan on studying spectra and stars. I'm still, I'll be applying this year. It's going to be pretty hard to get into graduate school, so I'm not even sure, at least for astronomy, because it's such a small program. So my backup will still be physics. So some of you have been following me for a while, you know I'm getting a double degree. I'm getting a degree in physics and astronomy. So, I'll be pretty primed to go into either one. My preference will be astronomy, but, I'll go, either way I go, I want to go to graduate school in the fall. So if need be, I'll just go for physics, but I plan on going in the fall out of the way. But my primary focus will be astronomy, and it'll be, right now I'm studying the nearest star because I don't really have the technology to study the distant stars yet. But if I get into an astronomy program, I'll be able to use their telescopes and spectrographs and so on and so forth, and uh, and study some more distant things. Now, this rendition of my uh, pictures is actually I took a pretty advanced, but yes, they were free, image editing software, and I rotated it because when I first put the images in a slideshow, I was able to discern the rotation. So the rotation, if you can see my mouse here, or maybe you can't, but it's on the right side of the image. So the right side of the image, if you look closely, like at the spot on the right side, you'll be able to see how that spot gets more closely to the right side of the image. So I'll go ahead and play the rotation. Maybe they're kind of hard to see, but look at the spots on the right side, and you'll be able to see how over time, over this 4-hour period, you can see the time of the image at the top in Central Time. The spot on the right gets closer and closer to the edge as the sun is spinning. So what I plan to do is actually, because one, at this point, I'll have to actually do some work on my telescope to fix the little thing that holds the camera because the camera's so heavy and the telescope is so cheap. So I'm thinking about going to like Home Depot and like drilling some extra holes around it, and I could use more screws to hold it in place. But that's not really necessary because what I'm going to do is focus more on the images from the Soho telescope, and I actually found another telescope as well I could get images from that takes images every day. So the Soho telescope takes images once a day. There's another telescope I found that I didn't memorize the name of. It takes pictures every day. So I could actually get pictures from that from a satellite every day as well. But still, I wanted to get my own images because I just think it's fun. So now we're nearing the end. If you see, that spot on the right side is closer to the edge. Or maybe you can't see, but I looked at it back and forth a few times. I was able to see the difference. What I'll do is pause between the sort of last images and go straight to the early images. So that's one of the early images around 11 a.m. And now I'll go back to the evening images, and you can see it's a little bit closer. It's a little bit closer to the edge, showing the rotation. So look at it one more time. The spots to the right, and look again to the left. It's a little bit closer. It might be hard to see for you all on the screen. But before I looked at the satellite images to determine the rotation, I found the rotation in my image first, and I realized that the rotation is going towards those two sunspots on the right. So now what we're going to do is look at, those were my images. Now we're going to look at the images from the big bad NASA folks. I don't even know if they're specifically NASA, but other people, anything that's from any university or whatever they call it NASA. But this is an image from a satellite that's in space. Now, if you notice, now I'm gonna actually scroll through first of all to my to the day that I took the images, and we can compare real fast. So cool. And by the way, I have this set to go 1 day per second. So let me pause this, and I'll go to the 3rd. So this is August 3rd. And actually, gotta pause the date. Let me just remove the date range momentarily. But the date range is so small, I sort of made it separate. So now it's kind of hard for me to see. But the 3rd should be about here. I went a little bit ahead. Let me look closely. There we go. So that's an image from the 3rd. So that's an image from the satellite from the 3rd, right? And this is mine from the 3rd. So as you can see, it's the same exact sun. It's just those are in more detail. So if you look at the spots, the position of the spots is actually the same. They're in space, and maybe I should find a better image on mine. Let me try to find a better, because this is like one of the poor image ones. Let me see here. Let me scroll through and find one that's relatively clear. And that was a good one. Pretty good. See if I can find one. I got better at my cropping as I went. Okay, that one is pretty good. So that's one image of mine from the 3rd. And this is an image from the satellite in space. So as you can see, it's the same image, just theirs is better because theirs is in space. So it makes it look a whole lot more awesome. And so what I'm gonna do now is transition to the satellite images. And what we can do is I'm going to scroll through about a month of satellite images, and you'll be able to see how the spin that I saw in my images matches the spin of the satellite. So let me restart this. It should start from the July, and there we go. So let's take a look at this. Now this is, hold up, they're both not spinning. What did I do? I think I still paused my images. Hold up. Let me try this again. So I'll stop, and I'll stop the date range as well. I'll see if they both show. No, so the days might be just a bit off. So you just have to bear with me with that. So the day might be a day behind. But suffice it to say, uh, each of these. Oh, hold up. Oh, I think I broke it. There we go. Now it's going. So the dates again might be a little bit off. But suffice it to say, my images I took like hundreds over the course of 4 hours, and I picked out the best ones. Each image is one day. So each of these images is one day. Let me just remove the date range because I know the date is off. So what we're seeing now is we're seeing every single image is a day, and we're seeing how the sun is rotating each day, right? So I think that's pretty cool. So what I'm going to do is I'm going to study these sunspots. Now it's just reset. So now it's reset back to, so this is close to what the days were. Let me see if I could just start both of them at around the same time. So these are about the accurate days there. So what I'm going to do is I'm going to study these sunspots from the satellites, and I'm going to determine the rate of spin by seeing, how the sunspots are going around. And even now, I mean, we can get a pretty rough idea. Like if we look at the sunspot that just came over the edge, we can just count. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So roughly we can say that's about 11, 12 days for half a spin. So about 22 days for one spin. And then I'll have to take into account, have to see how much the rotation of the Earth plays into that. Not the rotation, but the revolution of the Earth around the sun plays into that. The good thing is, the one interesting thing about the solar system is, I'll bring up some images of protoplanetary disks, but the solar systems form from protoplanetary disks, which now we have satellites that can look far enough into space where we can actually see some of these forming. And what happens is these clouds of dust start to coalesce, and the central region becomes a star, and the outer regions eventually coalesce into the planets. Let me save this image somewhere, and I'll show y'all some images of a protoplanetary disk. So, boom, this thing will open. There we go. Um, and why don't I add, let's say, a uh, what application, media source, uh, window, add a window. And good. It's already actually in Chrome, so I'll add the Chrome window. Boom. So this is an example of a protoplanetary disk. So these are actual satellite photos of protoplanetary disks. And basically, when these large gas clouds, and they also have other elements because nowadays, since the universe is pretty far along, there's been enough supernovas where, like, the sun is composed of not only hydrogen and helium, but there's other elements that were forged in the furnaces of other stars. When those stars supernovaed, it sent those elements out. So basically, some of the heavier aspects of these clouds become the rocky planets like Earth, and then the central part becomes the stars. Now, these things are revolving, like these whole clouds are spinning. That's why all the planets revolve in the same direction as the sun, because they were all spinning at the same time and coalesced. So the interesting thing about the rotation of the sun, we revolve around the sun, in the same direction that the sun revolves. The only time we notice solar, I mean, there are solar systems that are different in that way, but usually our understanding is because there's been some kind of cataclysm. Like, for instance, there's some kind of large body comes in and hits one of the planets, and eventually the revolution is reset, and maybe one of the bodies are now going in the opposite direction. Usually, there's like one that's going in the opposite direction. But normally, when we see planets in the solar systems, like when we look in deep space and look at other solar systems and see the planets around them, they're generally all going in the same direction. So I think that's pretty cool. So what I'll do is I'll take a look and I'll try to estimate the rotation of the sun and see what I can find before I really look into it. I'm pretty sure, astronomers know how fast the sun is rotating, so it's not like I'm going to make some kind of big discovery or anything, but I just want to know for myself, and I think it's fun. It's actually going to be one of my projects for my pre-graduate studies. And I'll also do some spectrograph. If anybody, or those of you who've seen my video that I made, that little short live video I made, I'm also taking some spectra of the sun. I've already done some preliminary investigations, and I found mostly hydrogen is in the sun. I've also found some other things, like I believe sodium, but I didn't memorize it yet. I just did the preliminary investigations last night. But that'll come in the future. Still working on that. But I'm farther along on my rotation revolution. So I know I saw Hurry here, I saw Luke in here. Y'all have any questions, any comments about the images or anything before I close up? Maybe I'll put my images and the solar images side by side, and use my images and the satellite images side by side. So the left are the my images, and the right are the satellite images. And let me know if y'all have any questions about anything or comments. But pretty proud of my images. It took me months to be able to take images like this, working on it. There's my copyright for the images, but it didn't fit into the screen. Or if anybody else is watching my little what do you call it? Live control panel inside my program is not working properly, so I can't see how many it's seeing right now. But I think that's pretty cool. Let me get mine playing as well. So again, mine was over the course of a day, around 4 hours. And for some reason, mine is not playing. I guess I got to get used to these uh, slideshow Jinkies. Let's see here. Visible. Let's play. Let's see if that works. There we go. So mine is over the course of a day, 4 hours within one day. And the one on the right is from the satellite, where each image is one day. Each movement of the image is a shift between one day to the next. So preliminary estimate, which y'all see me get here, is that the sun is rotating about once every 22 days. Looking at those solar spots there, and in 22 days, I mean, we move about 22 degrees around the sun. So technically, I guess we would actually detract from the revolution that we're seeing. Our motion around the sun would detract from that. So I have to actually add to the speed of the rotation, but I'll get that worked out another time. But I wanted to whet the appetite of those who are interested in those images, and more detail will come in the future. I'll have it more worked out and more detailed, and I'll probably do a proper presentation when I get the amount of rotation worked out in detail, and that'll be coming in the future. So I don't see any questions or anything now. Thank you all for who all watched and liked, and I'll be back probably throughout the week next week. Two of my classes I finished, got all A's this semester again. So I have the potential to graduate with an A average, with a low end average, but I have to get A's and everything going forward, which I've been able to do for the last 2 semesters. um, which means I think I may have gotten university honors again. I got university honors in fall of 23. So that would mean, as long as I had enough hours, I got university honors. Uh, I actually dropped one of my classes in the spring, so I may not get it for the spring. 6, 20, but still I did well. So I got my schedule worked out better now, and I have to get it worked out because this is my last year, so I'll be graduating next year. So wish me luck, wish me well. So hopefully I can make A's on everything again, but we'll see how it goes. But get some. So far I've gotten A's and B's and everything. I got one C, well C plus, but still it's like the lowest grade I've ever gotten so far. But oh crap, and my mind stopped. Let me see if I can get mine going again. Uh, let's see here. There we go. So I guess I gotta just hit the next arrow and it starts up again. But awesome. But if y'all anybody have any questions about it, uh, that one invisible. This one I want. So if anybody have any questions about the images, the rotation, let me know, and I'll maybe respond in a different video. And if anybody have any comments, let me know as well in the comment section. I'll be back on that. And be sure to let me know if you want any tutoring math, science, astronomy, physics, a little bit of chemistry. So I've only taken chemistry 1 and 2, which is what I have to take for my chemistry degree. I see why it's necessary because as you get into spectroscopy and the atomic, the shifts of the electrons, chemistry definitely helped me with that. Even the photoelectric effect, which I remember right was mentioned in chemistry, that comes into play as well. But any of those subjects I made an A or a B on, except for waves. That's the subject I made a C plus in. It was just a hard class the way it was designed. So but I actually did some studying on my own on it. So I was confident enough to go into my quantum class, which is going to be this fall. I'll be taking quantum physics 1. And so wish me luck on that. I took linear algebra this summer, which prepared me for that. Tried to take it before without taking linear algebra, so that was a bad idea. So wish me luck when I take it this fall. I'm pretty sure I'll do well. And thank y'all for joining. Good seeing Hori and Logan, and I'll see y'all next time.